students, today we have to continue the second part of the activity 5, nature of nervous message, recordable electric signals. Don't forget to prepare your notebook and a pen and to open your biology book pages 72 and 73. At the end of this video, you will be able to define an action potential and to list the phases of an action potential. Let's remember, when the nerve fiber is not transmitting messages, we say that the nerve fiber is at rest. So we are talking about resting potential since nerve fiber is at rest. While sometimes when we are making any action upon a stimulation, the nerve fiber is transmitting messages now. So the nerve fiber is in action. So now we are talking about action potential. What is an action potential? What should we do to create an action potential? What is the value of an action potential? Don't forget that the value of a resting potential is minus 70 millivolt. But what is the value of an action potential? To know the value of an action potential, we should bring an axon and a voltmeter or an oscilloscope to record the value of an action potential. Then, of course, we have to stimulate this axon to create an action potential. After the stimulation, we obtain a value of plus 30 millivolt. This is the value of an action potential. So, till now, the potential difference increases from minus 70 millivolt when it was at rest to plus 30 millivolt when it's in action. This is the recording given by the oscilloscope. But how did we obtain this recording?
As a result, a wave of positivity moves down the axon without any individual ion moving very far.
What are the charges inside and outside the axon before the stimulation? I will repeat the video and compare the charges before and after the stimulation. Before the stimulation, the axon is positively charged outside and negatively inside, while upon a stimulation,
as a result, a wave of positivity moves down the axon without any individual ion moving very far.
The charges are inversed. So, before the stimulation, we have positive outside and negative inside, while after the stimulation, the charges are inversed, negative outside and positive inside. This is called the inversion of polarity because the charges are inversed upon a stimulation. But what happened in the axon to inverse the charges? So, a modification, a change in the electric state of the membrane is called action potential because, as we said, it was positive outside and negative inside. After the stimulation, the charges are inversed. They become negative outside and positive inside. It propagates along a nerve fiber as a message. The stimulation was here, then it propagates till the second point, then to the third point, to reach the end of the axon. The nervous message or the action potential propagates by inversion of polarity. But how are the charges inversed? What happened exactly to inverse this charge? This is the axon. At rest, Na plus or sodium ions dominate in the extracellular medium while potassium ions dominate in the intracellular medium. So, the axon is positively charged outside while negative inside. While upon stimulation, we have now an action potential. So, the charges are inversed, negative outside and positive inside. So, what happened exactly to inverse these charges? One possible hypothesis we have is that sodium ions penetrate inside and inverse the charges. When sodium ions are outside and they can diffuse only to inside, when they penetrate inside, the charges inside will become more positive than outside. So let's verify this hypothesis.
Voltage-gated ion channels are passageways for ions in and out of the cell, and as their name suggests, are regulated by membrane voltage. They open at some values of the membrane potential and close at others.
Which channels are first open? As we see in the video, first sodium channels are open and sodium ions penetrate inside, so the charges are inversed, positive inside and negative outside. Then potassium channels, which are blue in the video, are open, so potassium ions diffuse or move outside the cell to re-inverse the charges as they are in the resting potential. To study exactly what happened during an action potential, first look to this recording obtained by an oscilloscope upon a stimulation. So, this part, the axon was at rest, so the potential difference is minus 70 millivolt. After the stimulation, the potential difference increases to reach plus 30 millivolt. It's the first phase of the action potential. Then it decreases to reach its initial value of minus 70 millivolt. It's the second phase. Then it continues decreasing to reach minus 80 millivolt. It's the third phase of action potential. So we have three phases in the action potential. But what happened in each phase? Let's see. This is the first phase. Phase 1. In this phase, sodium ions penetrate inside the cell. So the membrane potential increases from minus 70 to plus 30 millivolts. This phase is called depolarization. The second phase is the phase 2. Potassium ions exit outside the cell, so the membrane potential decreases from plus 30 to minus 70 millivolt. It returns to its initial value. This phase is called repolarization. We notice that the first phase and the second phase are like opposite, which means that in the first phase, when, for example, 100 sodium ions penetrate in the first phase, to increase the membrane potential to plus 30 millivolt, we need the same amount of potassium ions to exit the cell to return to the initial value. But it's not the fact that happened inside the axon. We have a third phase called hyperpolarization, which makes the membrane more polarized because of the excess of potassium ions that exit outside the cell, leading to a membrane potential equal to minus 80 millivolt. At rest, sodium ions, which are blue, dominate outside the cell, and potassium ions, which are green, dominate inside the cell. During depolarization, sodium channels open and sodium ions penetrate inside the cell. While during repolarization, look to the green circles, which mean the potassium ions exit outside the cell. Now we have to pause the video, prepare your notebook and a pen, and to solve the following exercise, then correct it. First question, the recording obtained between 1 and 4 milliseconds, so this recording is called action potential. The first one is depolarization. During it, the potential difference increases from minus 70 to plus 30 millivolt. Then the second phase, repolarization, when the potential difference decreases from plus 30 to minus 70 millivolt. And the last one is hyperpolarization, when the potential difference decreases to minus 80 millivolt. And the recording obtained at 6 milliseconds, it's equal to minus 70 millivolts, so it's the resting potential.